All right, folks, we're going to talk about position versus time graphs for constant speed. So you might want to label that in your notes. So when you're taking notes on play posits, record new formulas and hints, and you might want to do the practice problems. I disagree with that part. But definitely record new problems and hints, and I'll try to give you a particular heads up if something's important. Okay. Statement number one is you are going to have to retrain your brain that the x-axis is no longer the x-axis. I mean, it still is, but we're going to put time on the x-axis in seconds, and there you got your visual of a stopwatch. All right, so the x-axis is now time, not location, and the y-axis is now the x-axis, okay, or the location. So you're measuring where the object is on the ruler on this scale and the time that it is there on this axis. All right, I think that's going to make more sense as we continue to do some problems. So this object is not just a graph. When we say position function, we really do mean function. So if the graph were not a function, for example, this shape right here, if it didn't pass the vertical line test, what would that mean? It would mean that the object was in two locations, a little bit above 2.5 and whatever that is, 1.6 at the same time, right? That's what it would mean. It's in two locations at, three locations at the same time. So that's physically impossible. So when we say it's a function, that's what we mean. That's why it makes sense from physics. Okay, so you have two objects, runner A and runner B. Their position versus time is graphed. Which runner has a greater speed? All right, that is a trick question, even though runner B, let's make up some numbers here real quick. This person started at 0 and ended at 12 meters down the track. This person started at 6 meters, right? It had a start, but it covered the same ground, so it ended up at 18. So it's farther ahead, but it's farther ahead only because it had a head start. They both have the same slope, so they both therefore have the same speed. All right, and then fancy physics word is displacement. Delta means change. So my goofy joke of the day, and this little pencil, don't always have it, so don't say, but you didn't have a pencil there. When I do remember to put a pencil in, that means for sure write that down, because this is a definition. So delta stands for difference, delta and x together stands for displacement, and the goofy joke is displacement is the difference from this place to that place. But I'm bummed. So in this case, the displacement for both of them was 12 because it was 12 minus, I'm talking fast because I think this makes sense, 12 minus 0, or what do we have, 18 minus 6. Okay, so the difference is the same. Both people, or yeah, both runners move forward by the same amount, therefore they have the same displacement. Okay, so pause the video for a second and think about what this object is doing. And then state a time interval over which the object has negative displacement. All right, so the object started at 1, so they had a 1 meter head start, and then they moved forward at a constant rate. They got to 3 meters. Every time you look, oh, I'm still at 3, I'm still at 3. So they just sat there and chilled, checked their phone, whatever. And then the number started getting smaller, which means they're now backtracking. They're like, oh, they looked at their watch. They realized, I have enough time to go back and do whatever. And, you know, I forgot something. I do have time to go back and get it. And then they ran back because you can see that the numbers are decreasing faster. The slope is steeper. Okay. So negative displacement just means that the object ended up with a lower number than it started. So it could be this time segment right here. So I said a time interval, right? So it could be from 6.5 to, what is it, 7.5? It doesn't all have to be negative though. So it could be from 3 seconds to 8 seconds also has a negative displacement, right? I started out higher than I ended up because I went forward and then I backtracked even more than I went forward. So if any two lines that you can, any 2 points on the function that you can connect with a negatively sloped line has negative displacement. Okay, so lots and lots of options. All right, this is a good one. Think about a time interval over which the object has 0 displacement. So 0 displacement means I just ended back up where I started. So from 3 to 6.5, ended up back where I started. Any 2 points that you can connect with a flat line is a time interval meaning from this point to that point, over which there's no displacement. Okay, so you gain points in some kind of game, board game, and then you lose points and you're back to where you started. All right, so now you're going to practice calculating the velocity of the object from t equals 6. So I should have said average because it's a time interval. It's not an instantaneous. So from t equals 6 to t equals 7. Okay, so this should have said average velocity because it's in a time interval of 1 second. And the symbol for average is a bar over top. So the average velocity in this time interval is the slope of the secant line, which is the same as the slope of the line. And long story long, I've got my Cami's not working anyway. It's a little, handwriting's a little sloppy, so I apologize. Try to fix it. But it's x2 minus x1 over t2 minus t1. Okay, so try to unlearn the habit of saying y2 minus y1 over x2 minus x1 because it's x, difference in x over difference in t. And it's not bigger minus smaller. It's not 3 minus 2. It's later in time minus earlier in time. So it's 2 minus 3. It's always final minus initial. You want the difference. So it's 2 minus 3 and 7 minus 6. All right. So I think you're less likely to make a mistake if you actually label the coordinates. Okay. And then take final minus initial, final minus initial. There should have been units here. I was just having trouble writing. And so you have minus 1 over 1 or minus 1 meters per second. I will take off a half a point on a test if you do not have units with something that should have units. Okay, so average velocity, pretty straightforward. Average slope, that's why you didn't need to see me walk through that. Okay, so this formula for average velocity. I think it's helpful to box formulas in your notes So that is the change in x over the change in time, or the slope of the secant line. Okay, and then find the average velocity from t equals 3 to t equals 8. I don't think, I'm just going to quickly go over how you would do that. T equals 3 is this coordinate, 2.25, to t equals 8, which is 1. It seems odd that that's not, yeah. Okay, 2.5. Okay. So again, you would plot the coordinates, which is 3, 2.5, and 8, 1, and you would take second coordinates minus first coordinates ratio to find that slope. Okay. Since my Cami's not working, it's not super pretty, not going to do that. I think you guys all got that. Okay. Draw a position versus time graph. So this is good practice because slopes of secants pretty straightforward, but thinking about what things look like a little bit harder. Two runners run a track. Each runner's velocity is constant. Finish line is at 16. So look over this information. You draw it yourself, and on the next slide, we'll see how you do. Okay. So a runner. First of all, the finish line is at 16. So this is the position function for the finish line, which is kind of interesting. Boring. It's flat. Every time you look at the finish line, it's in the same place. So that's what that looks like, right? Not very interesting, but helpful. Okay, so runner A has a 2-meter head start, and they cross the finish line at 12 seconds at a constant rate. Runner B starts at the starting line, but gets to the finish line at 16. So again, what's really cool logically, you can see in order to make that happen, this slope or speed has got to be greater. And then coming up, we're going to be talking about collisions, and you can see that in order for runner B to get to the finish line sooner, since he or she started behind, this is when runner B passed runner A. All right, so couple of new terms, but hopefully all of that is making complete sense. I think the term that people take the most time to process is displacement, or delta x. So make sure that you have that at your fingertips. That is it. Thanks for listening, and I'll see you in class.